What is a star? For nearly all of human history, people had no way of knowing what a star truly was. To ancient eyes, the night sky looked mysterious and sacred. Some cultures believed that stars were the souls of ancestors watching over the living from above. Others thought they were tiny holes poked into a great black curtain, letting light from some other realm shine through. The Greeks imagined heroes and animals placed among the stars by the gods, frozen into permanent pictures we still call constellations today. Nobody imagined that those tiny, twinkling points were actually some of the most powerful, violent, breathtaking objects in existence. So, what is a star really? Well, a star is a massive ball of gas, mostly hydrogen, with some helium mixed in, squeezed so tightly by its own gravity that its core becomes unbelievably hot and dense. Deep in that core, something remarkable happens. Hydrogen atoms get crushed together so forcefully that they fuse into helium, releasing a tremendous burst of energy in the process. This is called nuclear fusion, and it's the engine that powers every star in the night sky, including the one closest to us, our sun. Stars are born inside enormous clouds of gas and dust called nebula. Gravity slowly pulls clumps of that cloud together, tighter and tighter, heating up as it collapses until fusion ignites and a brand new star switches on. From that point, a star can shine steadily for millions or even billions of years, held in a careful balance, gravity constantly trying to crush it inward, while the energy from fusion pushes back outward, keeping it stable. Almost like an explosion and a collapse, both together, balanced, happening at once. Because gravity is so heavy, the star can't explode. Because fusion is pushing outward, the weight of the star is prevented from collapsing inward. Not all stars are the same, though. Some are small and dim, glowing a cool reddish color and quietly burning for tens of billions of years. Others are massive and blindingly bright, burning blue-white hot and living fast, sometimes for only a few million years, before meeting a dramatic end. That's actually why stars appear in different colors if you look closely. Color tells you temperature. Reddish stars are the coolest, yellowish stars, like our sun, are medium, and blue stars are the hottest of all. Eventually, every star runs out of fuel. What happens next depends entirely on how big the star was to begin with. Smaller stars, like our sun, will eventually puff up into a giant red glowing shell, then quietly shrink down into a small, dense, leftover core called a white dwarf, slowly cooling for billions of years. But massive stars go out with tremendous violence, collapsing suddenly, then exploding into a supernova, one of the brightest, most powerful events in the entire universe, briefly outshining an entire galaxy. What's left behind can be an incredibly dense object called a neutron star, or, if the star was massive enough, something even stranger, a black hole, where gravity becomes so strong that not even light can escape. Why do stars appear to shimmer? Next time you look up and stars seem to twinkle, that shimmer isn't actually coming from the star itself. It's the Earth's atmosphere bending the starlight slightly as it travels the last few 100 trillion miles to reach your eyes. That's right, trillions of miles. Every star you've ever seen with your own eyes, you're seeing as it looked years, centuries, sometimes even thousands of years ago, because that's how long the light took to finally reach you. We are, in every sense, connected to the stars. The sun keeps our entire planet warm and alive. Every heavy element on Earth, the calcium in your bones, the oxygen you're breathing right now, was forged inside a star long before our solar system existed. Scientists continue studying starlight to understand how the universe works, and space telescopes are now capable of studying stars and their planets from thousands of light years away. Someday, perhaps, humanity may build spacecraft capable of reaching another star system entirely, a journey that could take generations, but one that dreamers and scientists are already beginning to plan for. Until then, we'll keep doing what humans have done since the very beginning, looking up, watching those tiny points of light, and wondering just how far we might go someday.